All right, so now we're going to look at some examples of how to simplify rational expressions, as well as how to determine if there are any holes or vertical asymptotes. We're not going to worry necessarily about horizontal asymptotes with these. That'll come a little bit later. So right now we just also want to, instead of just simplifying, we also want to identify all holes and vertical asymptotes. Okay, so for example, in number 1, all right, so when we're looking at this, we can notice that the degree of the top polynomial is definitely going to be higher than the degree of the bottom. Okay, so if I factor these both out completely, and we're going to say completely, right, I'm going to leave it as 4 instead of doing like 2 times 2, but this is the same thing as 4 times x times x times x all over 4 times x times x. Now, we're going to try to simplify this thing just by literally factoring out all of the factors we can. Well, we have 4 here, x here, and x here, right? And so when we simplify this out, we get just x. And that's simplified. Now we want to identify, well, are there any holes, right? And are there any vertical asymptotes? Well, because there was nothing left in the denominator that we couldn't factor out, we know that there are no vertical asymptotes. But we could factor out just x. Well, what does that mean if I can just factor out an x? Remember, right, I'm going to put a little note here, that x minus 0 is the same thing as x, right? So if that's the case, that means what I'm actually factoring out is x minus 0, and we actually do have a hole, right, at x is equal to 0, okay? Looking at number 2, again, we're going to do a very similar thing. I'm going to factor this out, but because I see a 3 on top and a 9 on bottom, I actually am going to factor the bottom into 3 times 3. So this is 3 times n all over 3 times 3 times, and then there's going to be 4 n's. 4, okay? Now, when I factor this out, I can get rid of 1, 3, and 1 n. Right, and so I'm left with, as far as this is concerned, so even though I factored everything out of the top, right, there's still going to be a 1 on top, and then I'm left with 3 times n times n times n, which is the same thing as 3n cubed. Okay, now that's it as far as simplifying. Now when we want to identify any holes and vertical asymptotes, right, again, because we have, we factored out in n, so it'd be a 0 essentially, but because in the denominator we actually have 3 of those n's, right, we're actually going to have vertical asymptotes and no holes, right? At x is equal to, or sorry, I put x, but it's n in this case because that's our variable that we're working with. N equals 0. Okay. So because again, even though we removed n, or n minus 0, right, we still had n minus 0 in the denominator. This is very similar to the last case of the last example that we looked at in the previous video. Okay, moving on. I'm only going to do probably these first 6, and I'm going to save the rest of those. The rest of those, since we do have 10 on this entire thing, I'm going to save the rest for you guys to work through on your own. Right, but for example, on number 3, right, again, I'm going to factor these both out completely, and when I factor the top, and again, I can use whichever method I need to actually factor these. Again, you can try doing like perfect squares, you can try, just actual factoring like we did before with the whole a is 1 or a is not 1, all those kinds of things. So on the top, because I'm looking for 2 numbers that multiply to give me -3 but add to give me -2, right, that's going to be p plus 1 times p minus 3, okay? And then on the in the denominator, I'm going to have p plus 1. Those are going to factor out, and so I'm left with is just p minus 3 as my simplified solution, or simplified answer. Now again, when we're looking at holes and vertical asymptotes, right, we'll notice that since I could remove p plus 1, that means that we have a hole at p equals -1. Now, there was nothing I could remove from the denominator, meaning that there was nothing in the denominator that couldn't be removed, so there are no vertical asymptotes. Okay. Number 4, yellow is a terrible color. Let's do that. Okay. 4, we're going to do the same thing. I'm going to factor this out, and so we should have x minus 2 over 3x times x minus 2. And so once again, we're going to see that, hey, we can factor out the x minus 2, and so I'm left with 1 over 3x, okay, and I can't simplify that any further. And so this is going to be a case where we actually have or both a vertical asymptote and a hole. So because I could get rid of the x minus 2, right, we're going to have a hole at x is equal to positive 2, okay? And because I couldn't get rid of the 3x in the denominator, right, then that means I'm going to have a vertical asymptote at x minus 0 or x equals 0, okay? For number 5, I'm going to use, let's go, we already used green, so let's go purple, why not? All right, again, I'm going to factor both the numerator and the denominator. All right, and so I should get, so I'm looking for two numbers that multiply to give me 3, but add to give me a positive 3 and add to give me positive 4. Well, that's going to be b plus 1 times b plus 3 all over, and then two numbers that multiply to give me negative 6 and add to give me positive 1. Right, and that again is going to be b plus 3 times b minus 2. Okay. Now, if I simplify these out, I can see that we have we can remove b plus 3, so I'm left with b plus 1 over b minus 2 here, and that's going to be it as far as simplifying goes. Because I could remove b plus 3, that means there's a hole at b equals negative 3, and because I couldn't remove b minus 2 from the denominator, there's a vertical asymptote at b is equal to positive 2. Trying to use a different color here. Let's go, no, you know what, let's just go black here. Okay. If I'm going to simplify these guys out, again, n squared minus n minus 6, right, that's going to give me n minus 3 times n plus 2. And I factor the denominator, which is going to give me n minus 3 times n plus 1, okay? Again, because two numbers that multiply to give me negative 3, but add together to give me negative 2. Now I can factor out the n minus 3, and so I'm left with n plus 2 over n plus 1. Okay? And again, since I could remove n minus 3, right, there's a hole at n is equal to positive 3, and because I couldn't remove n plus 1, it means there's a vertical asymptote, at n is equal to negative 1. Okay, and that's just kind of how we can do those, do these types of problems, and that's just as far as simplifying can kind of really go here. Okay. If you have any questions, please feel free to email me, or you can always visit, come to office hours. But good luck on the assignment today, guys.